Alright, welcome everyone to this video in our chapter 16 discussion of acid-base equilibrium. In this video we're going to be talking about salt solutions, okay, and how salt solutions can actually end up being acidic or basic and not necessarily always just a neutral solution. Okay. Right, and so the first thing we need to talk about here is what is a salt, right? We talked about electrolytes and things like that back in chapter 13 with colligative properties and such, okay? Right, a salt is specifically, right, again, referring to some sort of ionic compound, okay? It doesn't have to be sodium chloride, right? A salt isn't necessarily like table salt, right, sodium chloride, okay? Any type of ionic compound, right, is considered salt. And often in acid-base chemistry, when you react an acid with a base, you will form a salt. For example, right, if I react HCl plus NH3, HCl is my acid, NH3 is my base, this will form NH4Cl, right? In this case, there's no water being formed, but, you know, could form water, okay? Right, one example that does form water, right, if I react with NH4 plus, oh no, sorry, let's do a different example here. Let's say I have calcium hydroxide reacting with 2HF, right? This will form CaF2 plus 2H2O, okay? Right? So in these solutions, right, or in these reactions, NH4Cl and CaF2, right, are salts, okay? And so often acid-base reactions will form salts in solution, and those salts can end up changing the pH of your solution, okay? So how do they do that, right? How does a salt solution affect the pH? So, right, a salt has some cation and some anion. I'm going to just call them M plus and X minus, right? System of cation, anion, okay? Right, that gets formed in solution as they dissolve in solution, okay? Each one of those ions, right, could potentially react with water to produce some sort of acid or base, okay? And then it might produce hydroxide or protons, okay? Right, and these reactions with water are called hydrolysis reactions. Okay, if anything reacts with water, it's called a hydrolysis reactions. Okay, and if something will actually react with water, it's going to be some type of acid-base reaction, and it will change the pH. Okay, right, and so depending on the salt, the pH of your solution could be acidic, could be basic, it could be neutral. Right, right, because again, the M plus ion could react with water in this hydrolysis reaction to form HM plus OH minus, right? In this case, this is acting as a base, and our H2O is acting as an acid, right? And to form a conjugate acid, HM, right? And then X minus, right, could react with H2O to form HX. Oh, I messed up on that first reaction here. Let's rewrite this products, okay, right? So 8M plus H2O, right, will not form HM, right? This will form MOH plus H plus in solution, right? Okay, and so in this case, what's actually happening is M plus is acting as an acid, and H2O is acting as a base. Okay. In this reaction, X minus reacts with H2O to form HX plus OH minus. X here is acting as a base. Water is acting as an acid, right? To form our conjugate acid here. Right, and OH minus, okay? So, what are some examples of ions that might react with water, okay? Might form weak acids or weak bases, right? So, for example, acetate, right? this itself we talked about is a weak base, right? So this weak base will react with water to form OH minus ions in solution, as well as the weak acid, right? Ammonium is a weak acid, so it can react with water to form hydronium ions and NH3, its conjugate base, okay? Now, the ions that don't impact the pH of a solution are ions that come from strong acids or strong bases, right? So they're conjugate acids or conjugate bases of a strong acid or strong base. So again, this is a reason why we need to remember our strong acids and strong bases to identify that, hey, every one of these ions that are conjugate bases of a weak acid, okay, and actually let's not talk about HSO4, right, because HSO4 itself will act as a weak acid, okay? But the rest of these guys, okay, Cl minus, Br minus, I minus, so on and so forth, right? All of these things came from a strong acid, so they will not do anything in solution. They will not change the pH at all, okay? Similarly, these cations, sodium, lithium, calcium, barium, right? These 2+ cations, right, are all coming from strong bases, and so they themselves are negligible acids, right? They will not act as an acid, they will not affect the pH, right? So these lists of ions here do not change the pH of a solution ever. And these typically act as spectator ions in most chemical reactions, okay? Just spectator ion is, right, it's just an ion that does nothing in the solution, right? Isn't involved in any chemical reaction, okay? So if I want to figure out the pH of the salt solution, right, we first are going to assume the salt completely breaks apart, okay? And we got to look at what the ions are in solution, right, to determine, hey, if it came from a strong acid or strong base, not going to do anything, right? Right, they're just strong electrolytes, and they're just going to hang around in solution doing nothing, right? Now, if it came from a weak acid or a weak base, then it will react with water to form that weak acid or weak base, okay? And these reactions will then affect the pH of your solution, okay? So in general, right, when these ions break apart in solution, right, the question is where did they come from, right? If your salts came from a strong base and a strong acid, right, for example, we have Cl minus and Na+, right, then it's a neutral salt. Solution stays neutral, nothing happens, right? Let's say your cation came from a strong base, like Na+, but your anion came from a weak acid, like the CH3COO-, right? Well, this itself is a weak base, so it will form a basic solution because it will react with water to form OH ions in solution, right? And then let's say my cation is a weak base itself, okay? Right? Then that weak base, right? Let's say it's NH4+, right? NH4+, it isn't a weak base, right? It comes from a weak base, okay? Right? This is the conjugate acid of a weak base, NH3, okay? Right? And so if my ion is NH4+, which is a weak acid because it's a conjugate acid to the weak base NH3, right? Then this NH4+ in solution will make an acidic solution because it will react with water to form H+ ions in solution, right? And then if you have your cation is the conjugate acid to a weak base, and your anion is a conjugate base to a weak acid, then the solution could be basic or acidic. It really just depends on the strength of these acids and bases, okay? And it's a lot more difficult to tell. Okay, so how would you calculate the pH of a salt solution, right? So if it's not neutral, right, a neutral solution has a pH equal to 7, right? Right, pH equals 7 for a neutral, right, solution. Okay. Now, if I don't have a neutral solution, right, if one of my salts is, say, F, right, NaF. Let's say that's my salt, right? Sodium is a spectator ion, right? This thing comes from a strong base, so it does nothing, okay? And then F minus comes from a weak acid, so this itself is a weak base, right? So what we'll need to do is, if we aren't given the Kb for this weak base, we need to calculate the Kb from the Ka of HF, okay? And we write out the equilibrium established, right? The F minus plus H2O going to HF plus OH minus, okay? And we make an ice chart, right? In our initial change equilibrium, fill in this chart and solve for your change so that you can find what the equilibrium concentration of OH minus is, okay? Right? And then from there, you can potentially find the pH, right, by converting that to, say, POH, and then using pH plus POH equals 14 to solve for pH, right, however you want to do it, okay? But that's kind of the typical procedure we would need to follow to find the pH of a salt solution, okay? So again, we'll do plenty of examples of these in class, right? But for here, just kind of outlining how we approach these type of problems.